Okay, how's it, guys? Let's have a look at, let's use some red here. Let's look at example 2.2. In the previous video, we looked at example 2.1, graphical representation, and we saw this graph with a curve, the XT curve. And we answered these questions, A, B, C, D, and we got these answers. So the idea here was we had a graphical representation, meaning we had the curve, and we used that to answer questions from the curve itself. In this problem, or example 2.2, we actually have an equation describing this curve. Let's write it out here. xt, it's going to be minus 2t squared plus 2t plus a half. All right, so there is that equation, and you'll see that this pretty much plots this curve. Okay, so this is the mathematical representation of that curve. Now, question A, we're going to try to fly through this. Question A, so we're looking, the answer is 1 meter, but what is it? What's the question? What was the x coordinate of the object at 0.5 seconds? So when we looked at the graph, we came to 0.5 seconds, we went up and we hit the curve and we found what the position was at half a second. Well, how do we do this if we use the equation? We're saying what was the x coordinate at a certain time. So here we have x at t equals a half, and we just substitute a half in here, 0.5 squared plus 2 times 0.5 plus 0.5, and you'll get 1 meter. Okay? Now, B. At what instant or instance did the object reach x equals 0.8 meters? Okay, so on the graph, here's 0.8. So if you recall, you can see it cuts it at two times, somewhere around here, 0.2 roughly, and 1 point, oh no, there it is, sorry, roughly 0.8. So roughly at 0.2 and 0.8, that's what we got for our graphical one. How do we do that here? Well, we have to then say, we take this and we say 0.8 equals minus 2t squared plus 2t plus 0.5. If you rearrange this, you will get, let's see. You'll get 2t squared minus 2t plus 0.3 equals 0. And if you want to solve for t, we can use the quadratic equation, minus b plus minus b squared minus 4ac square root all over 2a. I'll just plug it in. I won't do anything more than that. Minus b is going to be minus 2 plus minus b squared is minus 2 squared minus 4 times 2. That's a, and c is 0.3 square root and all over 2 times a, which is 2. And you'll see that you're going to get time equals roughly 0.18 seconds and 0.82 seconds. Okay, so now let's compare this 2 times, okay? 0.18 and 0.82. On the graph, we saw that the answers were roughly 0.2 and 0.2 and 0.8, 0.2 and 0.8. These are estimations based on just looking at the graph. But if we've got an equation that gives us the exact answer, then these are the more correct answers based on the actual xt function, the actual xt mathematical equation. Okay, but you can see they're very close, 0.18 versus 0.2, and we have 0.82 versus 0.8. All right, let's look at C. What is C saying? What's the question for C? C says, what distance did the object travel between 0.8 seconds and 1.2 seconds? So the graphical one was, we looked at 0.8 seconds, and we looked at what the position was, and we looked at 1.2 seconds, and we looked at what the position was, and we estimated the distance. If we do it here, we're going to have to say x, what is x at t equals 0.8 seconds, which is then minus 2 times 0.8 squared plus 2 times 0.8 plus 0.5, and we'll see that that equals 0.82 meters. And what is x at t equals 1.2? And you'll see, you'll plug that in again, and you'll get 0.02 meters. Okay? And so the distance then is, it moves the, I don't even know what was this? Was it a particle or what? It's just says an object. Okay? The object moves from this distance to this distance. So it's from 0.82 to 0.02 meters. So that is, it moves from 0.82 to 0.02. So it moves 0.8. Remember, distance is always a positive scalar. Positive scalar. Meaning it has no direction. Distance is just the path that you traveled. So distance is equal to 0.8 meters. Okay? Please make sure you understand the difference between displacement and distance. Okay. Then D, what was D? D said how long, asks how long did it take for the object to move from position at 1 meter to the origin, x equals 0. So how long did it take to move from there down to there, back to there? So our estimate was from 0.5 to roughly 1.2, and it was 0.7 seconds if you recall. Now how do we do this using this xt function? So we need to move from 1 meter minus 2t plus 2t minus 2t squared plus 2t plus 0.5. So this is, that's x equals 1 meter. And if you solve for time here, you're going to get half a second. And then the other one is 0 equals to minus 2t squared plus 2t plus a half. And here, you're going to get 2 times. T equals minus 0.2 seconds and 1.2 seconds. Now, why do you get 2 times here at x equals 0 meters? Why? Well, if you look at this curve, if you carry on with this over here, it's going to cut the x-axis there. Cut the x-axis there. So this curve cuts the x-axis at 2 points, 1.2 seconds and minus 0.2 seconds. Okay, so those are the roots of this equation. Where is x equal to 0? Well, this equation tells you at 2 places, minus 0.2 seconds and 1.2 seconds. The one that we're interested in, however, is only this one. So we discard that one and we say, how long did it take to move from 1 meter to 0, back to the origin? It took 1.2 seconds minus 0.5 seconds, which is 0.7 seconds. Okay? So guys, I love these two problems because the one, you have to solve these questions using a graphical approach, and this one you need to solve the same questions using a mathematical approach. Okay? Good luck.